Hello, my name is Norbert Kamiński, and today I'll present you possibilities of integration fwupd LVFS with OPNsense and pfSense. I'm working at Firmware Embedded Consulting System. So let's start my presentation. Let's begin with agenda. Okay, I will start with project genesis, then I will go to overall information about fwupd. After that, I will go to fwupd tool architecture, and I will go to pfSense proof of concept work and OPNsense proof of concept work. At the end of my presentation, I will tell you about existing issues, and then I will go to our future steps. At the end of my presentation, there will be also time for questions and answers. Okay, let's start with who am I. My name is Norbert Kamiński. I'm Embedded Systems Engineer at Firmware. I'm also open source contributor, mostly to fwupd and Yocto layers. In my scope of interest are firmware upgrade tools, virtualizations, and embedded Linux. Here are the links of my social medias and another ways to catch me. Okay, who is Firmware? We are licensed core boot service providers since 2016 and leadership participants. We are UEFI adopters since 2018. We are Yocto participants and embedded Linux experts since 2019. We are also official consultants for Linux Foundation fwupd LVFS project since 2020. And we are IBM Open Power Foundation members since 2020. At the beginning of my presentation, let's answer the question why we want to do such integration as fwupd LVFS for OPNsense and pfSense. Routers are highly popular attack vector, so they must be secured in the proper way. The security of the whole system is not determined only by the software it runs, but also by the firmware. The mitigation of the vulnerabilities provided by the firmwares can be easily done with the firmware updates. To this purpose, you need proper update tools. And here comes fwupd LVFS. And that's why we want to do such integration for OPNsense and pfSense. Also, our products, basic firmware update integration and dash arrow, will benefit from this integration. Basic firmware update integration is a service that allows integrate firmware updates for your devices. And with this integration, we will be able to integrate firmware updates for routers. Also, open source firmware dash arrow will benefit from this integration because it has the firmware line for routers, and there then we'll be able to easily update the dash arrow with this integration. Okay, let's go to some overall information about fwupd LVFS. The fwupd LVFS is one of the most popular firmware upgrade softwares. It's mainly focused on the Linux, but some functionalities also works on FreeBSD and Windows. Most of the time, end users doesn't know what exact hardware do they have, so fwupd project can query the hardware for them, and it can check if there are some possible updates for their devices. The LVFS is the secure place to store firmware updates. It can be used by the manufacturer to upload the very updates, and then it can be deployed to the end users. So fwupd can be a good way to simplify the process of the firmware updates deployment for the manufacturer, and it can facilitate the firmware update process for the end users. Here is the architecture of the fwupd LVFS project. It is split into 3 layers, and let's start with the session layer. In the session layer, there is fwupd manager, which is the brain of the whole update process. At the beginning of the update process, the fwupd manager refreshes metadata, and it downloads it from Content Delivery Network. In the metadata, there are information about supported hardware and new updates. And fwupd managers query the actual hardware that is in the device with the fwupd daemon, and checks if there is any new firmware version. If there is, it asks the user if he wants to use it. If he says yes, then it's querying the LVFS and it downloads firmware update. It validates this firmware updates with JCAT file, which contains checksums and informations about signature. If everything is as expected, it sends firmware update to the fwupd daemon, and fwupd daemon connects with the actual hardware and writes new firmware binary to the hardware. At the end of the firmware update process, it sends the report to the fwupd managers, and fwupd manager notifies the end users about success or failure. And that is how the fwupd provides the new firmware to your devices. Okay, let's talk about Linux vendor firmware service. The LVFS is a secure service where manufacturers are uploading their firmware updates. The LVFS deploys the actual updates to the end user devices. Information about new updates are stored in the metadata, and metadata is also deployed to the end users devices. Actual updates is packed into cabinet archives. The cabinet archives contains firmware binary and contains a JCAT file. JCAT file is used to validate the binary. It contains checksums of the firmware binary, and it contains information about the GPG signature of the manufacturer. Also, the PKS7 signature is used to sign the firmware binary. Manufacturer is signing the binary during the firmware upload. So one who we trust is the manufacturer, and we are not relying on the fwupd LVFS signature. Okay, it's time to start actual core of this presentation, which is proof of concept work for pfSense and OPNsense. pfSense is FreeBSD-based open source firewall and router developed by Netgate. It features an unified threat management, multi-one, load balancing, and many more. In this proof of concept, we used pfEngine's APU2 router firewall board and pfSense in version 2.52 and fwupd 1.74 and FreeBSD virtual machine in version 12.2. The initial steps that were taken in this proof of concept work was installation pfSense at pfEngine's APU2. We used USB installation media to install pfSense on the pfEngine's hard drive. Then, after the installation, we need to enable FreeBSD package repo. So we went to the pfSense configuration package and we add FreeBSD entry to this configuration. And as it is mentioned in the documentation, the development of the package pfSense packages should be done in the virtual machine. So we used to this propose virtual machine FreeBSD 12.2. We created FreeMDEP's fork of the FreeBSD ports repository where we placed fwupd port for pfSense and OPNsense. And as you can see here, we've got makefile snippet of the fwupd. We used the newest version of the fwupd at that point. Here we've got the build dependencies. Here are libraries that are used by the fwupd during the build and during the runtime. And at the end of the makefile, there are Mason arguments that are disabling the plugins that are used by the fwupd and which are not supported by the FreeBSD. The next step of proof of concept work will be building the fwupd package and dependencies which are not available in FreeBSD ports. So we started with installation of the existing packages and dependencies of the fwupd in pfSense and virtual machine. Then we cloned our fork of FreeBSD ports to the virtual machine, and we've built fwupd dependencies that are libgusb, which is used by fwupd to connect with USB devices, libjcat, which is used to verify the packages of the fwupd, and library XMLB, which is used to parse metadata from the LVFS. And at the end, we have built fwupd itself. The created packages must be transferred from virtual machine to the pfSense. So to this purpose we used SCP, and once it is transferred to the APU2 board, we can install dependencies for fwupd and fwupd itself. So after that, the last step we have to take before running fwupd is starting the dbus service. Okay, let's go to the actual demo of fwupd working at pfSense. Okay, so we've got pfSense, and at first we run the fwupd daemon. So we are changing right now directory to the fwupd daemon, and we are running it. Okay, as you can see, the fwupd daemon just found the CPU of pfSense, and it found some external device that is connected to the USB. Right now I'm running the fwupd version check. Okay, it's working correctly, and then I'm running fwupd help message. Okay, and the next step is running fwupd get device command. This command shows supported devices, and that's why the CPU is not available right now in this log. Okay, and now I will try to downgrade the firmware of the external device. Okay, as you can see, the fwupd found the existing firmware for external device. It let me choose the device firmware version which I'd like to downgrade to, and after that it is asking me if I want to downgrade this device. Of course I said yes, and whole process is starting. The firmware cabinet is downloaded. After that it is decompressed. It is authenticated with libjcat, and device is restarted. Here is the problem right now with update and downgrade of the firmware, because it's non-issue when the lib library, USB library from FreeBSD is not seeing the device that was restarted, and that's because of the failure that will be seen in a moment. Okay, and we've got the failure. Of course, the failure is shown after get device, and device is now bricked. It's working properly. Okay, and that's the all for pfSense fwupd daemon. Now it's time for OPNsense proof of concept work. OPNsense is open source FreeBSD-based router firewall operating system, which is developed by DCGO. Our proof of concept work is based on OPNsense 21.1 and pfSense's APU2 router firewall board and fwupd 1.6.2. The pfSense and OPNsense are FreeBSD-based firewalls, and due to that fact, most of the pfSense work proof of concept work can be moved directly to the OPNsense. Because of that, I will focus only on the differences between pfSense and OPNsense, and I will not duplicate the previous slides. So the main difference between OPNsense and pfSense is that we build the fwupd in the OPNsense, not in the virtual machine, that is FreeBSD virtual machine. Most of the fwupd dependencies were taken from the FreeBSD package repository, and we applied our pfSense port on top of OPNsense ports, and it works mostly without conflicts. So it's possible to compile fwupd for OPNsense, and then also we ran it on OPNsense. Right now I will show you how fwupd works on the OPNsense. So let's go to the demo. So as you can see, we are running on OPNsense. We are running fwupd tool version check, and we are checking the possible devices. Well, that's all for this demo. Here is the list of issues that needed to be solved during the proof of concept work. This is the list of existing and past issues that we faced during the fwupd porting. So let's start with which is lack of etc OS release file, which is missing for pfSense and OPNsense. So once we've created one empty file manually, it let us run fwupd tool correctly. The second problem directly connected to the OPNsense is that on FreeBSD 12.1, including malloc h causes the compiler to throw an error. So the malloc headers files needs to be replaced with standard library header file, and that problem is fixed in the FreeBSD 13.0. Next problems are connected to the exact plugins that are running by the fwupd. So if you want to add crucial plugins to the pfSense and OPNsense, we need to add the support for GCC 10, which isn't available in the OPNsense repository. Also, we need to add SRT support and FEVAR support. Also, here is the list of the future steps. At first, we need to find a founding for our future work. Then we need to fix the issues that we faced and we've described on the last slide. And then we want to add the support for new fwupd plugins. And also we want to constantly upstream our work to pfSense and OPNsense. So if you are interested in fwupd integration for your device, please contact us. We are open to cooperation and discussion. Here are the links that you can catch us. Also, feel free to contact us if you think that we are able to help you in any way. Many thanks to my colleague Michał Kopeć, who did OPNsense proof of concept work, and he helped me a lot with this. Thank you for your attention, and now it's time for the questions. And these CVEs are patched in newer versions of the firmware, and if we would have some tool to upgrade our firmware, it's our boards would benefit, and the security of the end users also would benefit. So that's the main genesis of this project. So I'm waiting for more questions. Thank you. Also, if you had any feedback for that idea of integration, OPNsense, for integration fwupd for OPNsense and pfSense, I would really appreciate that. So, Rodrigo, I guess it's all from my side. From my presentations currently. Oh, someone is typing. So maybe let's wait. Okay, so once again, thank you for your attention. And if you have any questions, I will be available in the hallway, and you can ask me after my presentation. Thank you once again, and maybe see you in the next year live in Brazil.